Copernicus passed away in 1543. We now move ahead a couple of decades to the later portion of the 16th century and then into the early 17th century. And we get to two people, contemporaries, Tycho Brahe and Johannes Kepler. It's now late 16th, early 17th century. Tycho Brahe and Johannes Kepler. Okay, first of all, Tycho Brahe. Tycho Brahe was lucky enough to be born into the Danish nobility. If you recall your basic European history of the time, basically society at the time was divided into two social classes. There were basically the nobles, the 1%, we would think of them today. The nobles basically held all of the wealth and they basically did nothing. And then you had everybody else in society who did all the work. You basically had the serfs. So Tycho Brahe was lucky enough to be born into the Danish nobility. Now, unlike his friends, Tycho Brahe actually decided to do something useful with his life. What he did using his own money is he built his own private observatory. And then over the course of decades, using his own instruments, he measured planetary positions in the sky. He concentrated most of his efforts on the planet Mars. The observations that Tycho Brahe made were by far the best and most accurate of their type that had ever been done up until this point in history. We remember Tycho Brahe today in part as one of the greatest observational astronomers who ever lived prior to the invention of the telescope. In order to measure planetary positions with the naked eye, however, you're basically measuring angles on the sky. You need large instruments, large means of measuring angles, versions of protractors that are called sextants and octants and quadrants and so on. Tycho Brahe's instruments were made out of steel and they were several stories tall. He then used these instruments at his own private observatory, which he built on a small island off the coast of Denmark. And then very carefully over the course of decades, he measured planetary positions in the sky. His level of precision was unheard of at the time. His level of precision was about 8 arc minutes, 8/60ths of a degree. If you take 1 degree and divide it up into 60 equal segments, you end up with what are referred to as 60 arc minutes. If you take an arc minute, by the way, and divide that into 60 equal segments, then you end up with what is called an arc second. So Tycho Brahe was able to measure planetary positions in the sky with a level of precision of 8/60ths of a degree. Now, why would Tycho spend all of this money and all of this effort doing this when, quite frankly, he could have just sat around drinking with his friends? Well, Tycho had his own pet theory of the solar system. His own pet theory of the solar system is called the Tychonic system, and it's kind of a compromise between Ptolemy's epicycles and the sun-centered universe of Copernicus. But first of all, Tycho Brahe. He very precisely measured planetary positions with an accuracy that was by far the best that had ever been done. Up until that point in history. His level of precision was 8 arc minutes, 8/60ths of a degree. And as I briefly mentioned, he concentrated most of his observational efforts on Mars. Once again, he did this because he had his own pet theory of the solar system called the Tychonic system. Here's the basic idea behind it. Tychonic system is a compromise between Ptolemy and Copernicus. It goes like this. Now, like Ptolemy, Tycho once again places the Earth at the center of the universe. So here's the Earth like so. And then, for example, we have the moon going around the Earth. And then we have the sun going around the Earth. Let me go ahead and draw the sun right here. Okay, now here's was Ptolemy's justification for once again putting the Earth stationary at the center of the universe. If you assume that the Earth is in motion as it orbits the sun, which is what Copernicus was assuming, how do you then justify the following? Why don't we feel the Earth's motion? 400 years ago, that was a legitimate question to ask, and there was no easy explanation for it. That explanation doesn't come until a little bit later on. So then therefore, because we don't feel the Earth's motion, it was thought to be somewhat ludicrous to assume that the Earth is in motion as it orbits the sun. So then therefore, Tycho puts the Earth at the center of the universe once again. Here's, however, the compromise that Tycho makes. Like Copernicus, now Tycho assumes that all of the other planets are orbiting the sun. For example, like so. So let's say that right here is Mercury. Right here is Venus. Notice with this scheme that regardless of what time, regardless of where, say, Mercury is in its orbit around the sun, or Venus is in its orbit around the sun, as seen from the Earth, you're never going to be able to see either of those two planets at midnight, which would be off in this direction, like so, on this diagram. And then we have also Mars, Jupiter, and Saturn. Mars, Jupiter, and Saturn, however, are orbiting the sun. So these circles here for Mars, Jupiter, and Saturn, and so on, are not centered on the Earth. They are instead centered on the sun. So you have this compromise, if you will, between Ptolemy and Copernicus. This is then what is referred to as the Tychonic system. So basically, Tycho's idea is to use all the data that he is amassing to then prove the correctness of the Tychonic system. In other words, take all the data that he's obtaining of planetary positions in the sky and then use all that data to prove this picture. And then if he proves himself correct, then he's going to be remembered forever and blah, blah, blah. That's basically what his motivation was. Now, as good of an observational astronomer as Tycho was, he didn't frankly want to bother doing the grunt work. He didn't want to bother doing the math. He didn't want to do the mathematics that would be necessary to take all of this data that he had amassed over decades and then apply that data to this idea to prove the correctness of the Tychonic system. So he basically hired somebody to do that. The person that he hired to do that was Johannes Kepler. I'll get to that in the second lecture of this series in just a few moments.